Hello all and welcome to the new video. In this video we're gonna see what is binary search. Okay, so let's just take one array. Okay, binary search is nothing but a searching algorithm, right? We need to find out a particular element is existing in array or not. Okay, so let's say we have this array. Okay, we have the line here also. It is of 7 length. Okay, 8 7th. Okay, let's say we have here elements as 1 2 3 4 5 6 7 and 8 element. Okay, and I need to find out where my 4 is present, or I can say 8 is present. Okay, 8. I will take 8. I will take 8 date as 8. I need to find out 8. Okay, where this 8 is present. So what is my brute force approach? Okay, so my brute force approach is to check all the elements whether you are 8 or not, and we will ask them whether you are 8 or not. If not, then go and check the next element, and next element. This is what linear search is. Okay, and it has time complexity of big O of n. Okay, because we are traversing through all the array to search one number. Okay, fine. But to reduce this time complexity, one new method of searching is introduced. This is binary search. Okay, for now, what are steps involved? Binary search says, first of all, I can just make my, okay, why does I say, first of all, calculate the mid value. Okay, what is middle of this array? That is, suppose I'm taking here 1 is low, this is my low, and this is my high. Okay, this is my low and this is my high. Now I have to calculate what? I have to calculate the mid value. Now what is my mid here? So low plus high by 2, right? I can say low plus high by 2, which is what? 0 plus 7 by 2, which is equal to what? Which is equal to 3. Okay, go to the third index. Okay, I'm here. Now I am at this position. My mid is pointing at this position. Now check this. Check ARR of mid. That means check on ARR third whether my data is present or not, or whether my data is greater than my mid value data or it is small than my mid value data. Okay, so there will be 3 conditions, right? There will be 3 conditions. And what are those 3 conditions? Whether my data is greater than ARR of M, right? The mid value index data, or I can say whether my data is less than ARR of M, or my data is equal to ARR of M, right? In the third condition, we don't have to do nothing. We will just return we can just say that my data is found at the M index. Okay, in the third case. But what about this first and the second case? Okay, so what about the first and the second case? I can say here that if my data is greater than my mid value, that means in this part, just look at carefully, in this part, there will be no presence of my data, right? Why? Because in this part, we have the smaller elements, right? You can see that we have the smaller elements. And so I can say, make my low as what? Equals to mid plus 1. Make my low as mid plus 1, right? So I can say that make my low as m plus 1. Okay. Now again we are doing what? Again we are doing what? We will calculating the new mid, right? This new mid. Okay. We will be calculating the new mid because I know I have discarded this data. I have discarded this data. Okay. Because my data doesn't lie in this type of presence. Now, low is high. Now 4 and 7. Okay. Now my low is 4 and high is 7. What is my mid? 4 plus 7 divided by 2. That is 5. So my new mid will be on at 5th index, right? And the 5th index. Now we will again check this condition. Whether my data is present or not, or it is less or it is greater. In this method, we have data as greater. Then again we will go to low as mid plus 1, right? So again we will take my low as mid plus 1. And it will come at here. Fine. Now again I will calculating what? I will be calculating my mid. So what will be my mid? Now 6 plus 7 by 2. That is what? 13 by 2, and 13 by 2 is what? 6. Now mid is here. I can say my mid is here. Okay. Now my mid is present. Then again we will check all the three conditions. Now data is greater than, then make my low as mid plus 1. Okay. And now low is also pointing to the same position and high is also pointing to the same position. Okay. Now again we will calculating my mid, and mid is nothing. I can say mid is nothing but the 8th, right? But this index. And again we will check. Now my data is present at my mid array, right? So I will return my index. Suppose now data greater than year of man condition is correct. Okay. Suppose let's just take I can just wrap it up. Let's just take, if my data is less than year of m, so I can just make another array with the same. See this, low is pointing here, high is pointing here, and mid is on, I can say there are 8 data now. Okay, so my high is pointing at 8. This is high, and what is my mid? Mid is nothing but what? 0, 1, 2, 3. This is mid. Now suppose I want to find out where my 3 is situated. Okay, so you can see that my data is less than my ARR of m, right? Now what I have to do, I will not find out the current data which we have to find in this type of high, right? Because there are numbers greater than my mid value. Okay, so I will discard this data and make my high what? Make my high to where? To my mid minus 1. I will discard this data full. Okay, I will discard this data. Fine. Now again I will check Now my mid is where? Mid will be here. Mid will be here because 0 plus 1 plus 2, 0 plus 2, 2, 2y divided by 1, that is my mid is here. Now again I will check mid. Now mid is what? Mid is 2 and my data is 3. That means my data is greater than my ARR of M. So where we will go? We will go to mid plus 1. My low becomes mid plus 1. So I can check, I can take my low where? To mid plus 1. Here. Fine. Now my mid becomes my mid. This part of the data will be discarded. Okay. Now mid becomes what? Mid becomes at here. This is my mid. Now again I will check whether my data is present. Yes, it will say yes, it is present. Then return from here. Return the second index. Okay. So this is the binary search. And there you can observe that we can apply binary search on the sorted array. Okay. Because for calculating the mid, in the left side we will have the smaller elements and in the right side we should have the larger elements. Okay. So this is the most important point, that is binary search is applied to a sorted. Okay. This is the most important condition, and this is the difference between a binary search and a linear search. Let's just try to compare it, the time complexity. You can see that we don't need to traverse the whole array. Okay, so my time complexity will be what? Big O of log n, and this is less than big O of n. That means my binary search is efficient than my linear search. Okay, let's try to code it and see. Suppose I have taken int ARR equals to same 1, 2, 3, 4 and 5. Okay, now my int L will be 0, that is an int h equals to ARR dot length minus 1. Okay, and now I will take what I have to find it up. In data will be, let's say 3. I'm finding 3, while my what is the loop? This loop will continue till my low is less than equals to high. If my low goes there, I should regret from the loop. I should break from the loop, because if my low goes again, if my low goes, okay, if my low goes here, then there is no use of high and low. Okay, high should always be greater than low. Okay, that is why it is high now. Okay, so my while loop is while low is less than equals to high, I will calculate what? First of all, I will calculate the mid, that is what? L plus h slash 2. Okay, if my data is greater than ARR of M, okay, then I will do something else. If my data is less than ARR of M, okay, then I will do something else my data is equal, hence I have find out my data. Just print what? Print the index and return from here. You don't need to check the again, right? Okay, so if somewhat my code will break from this loop, then it means data is not found. We should print what? Print -1. Okay, that means the data is not found. Now this condition, if my data is greater than what? Data is greater than ARR of mid. That means data is greater. That means we have to check on the right side. That means low should become what? M plus 1. Okay, should become what? M plus 1. L should become plus 1. If data is less, that means high should go before. Then I can say high equals to M minus 1. Okay, so I hope you understood the approach of binary search. Let's just try to run it and see where is my data is present. Let's just see what we have got. Okay, my data is present at the second index, 0, 1, 2. Suppose I'm taking data as 7. Let's just run it. My data is not present. So what it will be returning? Let's just try to find out. Yeah, it will be returning -1. So I hope you understood the concept of binary search. Okay, so let's just meet on next video. And if you like this video, please do hit the like button and subscribe to our Pepcoding's YouTube channel. Thank you.